Vale. Well, in this session, I'm going to present you a ZenWave SDK, a code generator for AsyncAPI, which was the first plugin that I wrote for the ZenWave SDK toolkit. So this started everything, and it's a code generator that can generate code for AsyncAPI, but also can abstract and generate code for you for some enterprise integration patterns. And well, it's an API-first code generator for Java projects with Spring. It's open source, and the code is quite recent, but the ideas that includes were battle tested for years, because this is the successor of a previous tool that I developed like about 4 years ago. And it was working in production for like 3 years. I believe it's still in production. So the code is quite new, but the ideas are battle test. So, well, the main question, why did I wrote ZenWave SDK for AsyncAPI if maybe there were already other code generators? And the answer is because we wanted to use the same API-first workflow that we were using with OpenAPI. I was working in an API-first strategy group on a company, and we were using OpenAPI very successfully, and we wanted to standardize how people write and read messages from the broker. So we didn't find in any of the tools. Okay, this is the workflow that we used. We use a Maven plugin, but we could live with a CLI or any other tool. And that plugin, that Maven plugin from OpenAPI generator, it generated for us some DTOs, a Java interface for the service. And if you are building a server, that interface will be annotated with some annotations for Spring MVC. And if you implement that interface, you are building a server. And if you are building you want to build a client to connect to a REST API, you will get one interface that it looks almost the same as the server one, but you get some implementation behind the scenes with different flavors. So you don't need to write any code. You just instantiate that implementation. You configure maybe the URL and maybe the authentication, and you can start sending get, post, delete, all the operations to that API. And we found, this was about 4 years ago, in the code generators that we found in the AsyncAPI toolkit didn't provide this workflow. And because this was our comfort zone, we decided to build it. Because we didn't find it, we decided to build it. Because these code generators, and if I'm wrong, or if I'm mistaken and they can do more now, please let me know in the questions, but they mostly help you generate just the models, the DTOs for your messages. And we wanted to standardize not only the models, but how people connect to the brokers, because every single project was writing and reading messages in their own way. And the first use case that we got for the AsyncAPI, for asynchronous messages, is to do some contract testing. So if we wanted to explore some contract testing strategy for the whole company, and everybody was writing and reading messages in their own way, well, it was crazy stuff. So we wanted that workflow with one single interface that was common for the whole company, and with different implementations behind the scenes. And when you upgrade the generator, you will get a different implementation, but your code still works the same. So this is the reason why we build ZenWave. And there is an exception because there is also, now, recently, there is also code generator, which is written in Singular. There are people here that has worked in, which is the multi-API code generator that follows a similar approach. It generates some interface and with basic implementation behind using Spring Cloud Streams. But ZenWave can generate the models for you. It can generate a business interface with some implementation behind. It can generate also a headers object, so you get typed headers. Because we are generating an interface with some flavors for the implementation, we can create some integration patterns for you in that implementation, just with configuration. So this is how it works. It's a code generator. It's written in Java with handlebars for the templates. Has a command line interface, but also a Maven plugin. Supports AsyncAPI version 2 and version 3. Actually, version 3, there might be some small glitches because maybe I didn't understand the changes altogether, but it almost supports version 3 already. It generates messages for the DTOs for the messages, the header objects, the Java business interfaces, and it can generate multiple flavors for the implementation. Right now, we are using Spring Cloud Streams, which has connectors for most brokers. So this is the schema. So from the AsyncAPI file, there is a code generator that you can run in your Maven project as your build, or you can run it in a pipeline, and it will generate a business interface with some DTOs, and the default implementation, which is Spring Cloud Streams. At runtime, you can use many different brokers to connect to virtually almost every broker. Because you are using just a Java interface, we can generate some code for some enterprise integration patterns, like a transactional outbox. We can do some exception handling for you. We can create an enterprise envelope, and this last one is very nice because we can fill the value or some headers for you automatically just with configuration in the AsyncAPI file. You can specify some runtime expressions, and we will fill the value. So, okay, there is a CLI and a Maven plugin, and well, there is something special about asynchronous event-driven APIs, and it is that they are symmetric. I think this is one of the main differences between REST APIs or HTTP APIs and event-driven APIs, because REST APIs are client-server and request-response. They talk together, they know each other, and they talk together synchronously. And event-driven are broker-based, which is a totally different beast, because which one is the server, which one is the client, which one is what is producing in one side is subscribing in the other side, what is subscribing in the other side is producing in the first side. So this brings a lot of confusion. We already know how much confusion. So how we do document our APIs? So when we were proposing this, adopting AsyncAPI and creating this plugin, which was about 4 years ago, we need to make some decisions. How to avoid duplication, which operation should I use? Should I publish? Should I subscribe? Should I use both? I create 2 APIs, one for this side, one for the other side, which is exactly the same, but the other way around. Should I create one different file for sharing the schemas between these two? But then if I use reference, where I put this file? Because if it's in GitHub, where our code was, you need authentication. If it's an open place, where is open? It's in the cloud, so people can work remotely, or it's inside the on-premise. it was a big mess. So our proposal, and it worked very nice for years, was to document your messages only once and from the perspective of the functionality provider. And well, this requires a little bit of explanation because we need to distinguish between provider client and producer consumer because they look the same, but they are different concepts. And for understanding the difference, we need to understand that the messages come into flavors. There are messages that are events. That means that they are informing that something happened already. I mean, if I'm the provider of one functionality and I'm informing the ecosystem of my company that something already happened, I'm publishing that event as the provider of this functionality. But if I'm a command, on the other hand, represents a request to start an action. So if I'm listening for a request to start an action and I'm going to start that action, I am the provider of the function. If I'm listening, I am the provider of the functionality. It may sound complex, but it's a little bit easier when you get your head around. In a nutshell, providers produces events and consumes commands, and clients consumes events and produces commands. And well, there are some tricks to know how to document your API, if you use the publish or the subscribe. But usually, if your message is an event, and there will be only one provider. And if your message is a command, it will be only one consumer. That's one of the tricks. But once you get your head around, it's quite easy. And once you find if you are the provider or the consumer, our proposal was to create the APIs only from the side of the provider and then configure the generator to generate the inverse code in the other side. So we avoid duplication, and we already have a way to know if you use publish or use subscribe. And what about the operation ID? Because we use like in the OpenAPI, we use the operation ID for generating some method names in Java. So this convention worked very nice for us. If we are modeling some event, we add a prefix which is on the event name, and if we are listening for a command, do command name, for instance, on customer event created, do create customer, and it works in both sides if you follow this convention. So I'm going to show you a little bit of how it looks to generate the code and what integration patterns we support out of the box. So, okay, we generate interfaces, DTOs, headers, and implementations. This is some Maven configuration. Don't worry, this is documented in the website. But there is one thing that I want to bring attention to, and it's here in the dependencies section. There are two Java dependencies, which are they are just Maven jars. Which one is AsyncAPI Spring Cloud Streams 3, which is a generator for ZenWave. So this is our standard generator for Spring Cloud Streams, but you can create your own. And if you want to create your own, you can fork this one. You can start from scratch. What I mean is that we don't expect that the code that we generate, it will fit on every team, on every organization. If you like it, you can use it. If you like it so, you can fork it. If you don't like it, you can create your own. And the other one is AsyncAPI JSON schema to Pollo. And well, it's another generator for generating the DTOs. And for configuring, we configure each generator and with some options. In this case, One execution is for generating the DTOs, and the other execution is for generating a provider with a style imperative. It's not reactive, because we also support reactive programming. And what it generates is an interface for the consumer and a class which extends a map with, well, it's collapsed there, but there are some static typed headers if you already configure it in your AsyncAPI. And for the producer, we generate an interface that it looks almost the same in both sides. So how you should use it? For the producer, you will get an implementation. So if you configure a Spring Boot context, you can auto-wire this interface, and you can instantiate the event DTO, the message DTO, you fill some data, and you use the event producer to send the event. And it uses the name that you configure in the operation ID. In this case, it reads like the operation, it reads like the domain code that you want to create, customer events producer on customer event. I mean, it is not the language about sending to the broker or reading to the broker. It's the language of your domain. And for the consumer, you implement the service, so you will get all the messages in your service. You only need to add the component to the Spring Boot context. And well, this is the schema because we have an interface. The only thing that I showed you here was the interface. The implementation that we gave you can have multiple implementation flavors. So these are one of the configuration options. You can create a provider or a client, imperative or reactive. You can expose a DTO or a Spring message DTO if you need to read some headers or write some headers. And it supports JSON and Avro. And for the integration patterns, it supports Transactional Outbox. So you can configure the generator to create an implementation flavor for you that will send your messages to the broker as part of a transaction. I mean, we have support for MongoDB and SQL. And for instance, if you want to send a message to a Kafka broker and you are using a MongoDB data store, if you store your data in MongoDB and then you send your message and the sending to the broker fails, but you already committed to MongoDB, you have a problem. If you inverse the operations and if there is a problem in the second commit, you also have a problem. So with the implementation that we created, we save, instead of sending the message directly to the broker, we save your operation and the message inside MongoDB in one transaction. Hopefully you configure it all right for being in one transaction, and there is a process behind the scenes that is sending the messages. So you can have a transactional outbox with no effort. I'm going to show you in a minute how easy it is to configure. And for business DeadLetter Queue, we provide some error handling for you out of the box, because when you're reading one message and there is a problem, there is an exception, maybe because serializing, or if there is some serialization problems, your broker is going to try again. Maybe there are about a number of retries. But if you already know that the processing of that message failed because of a business reason, some business rule that is broken, some validation, there is no point in throwing an exception and your broker sending again and retrying the message. So we provide some exception handling that you only need to configure, and we will get which exception you are sending, and we are going to send that message to a DeadLetter Queue, which is a business DeadLetter Queue. It's not an infrastructure DeadLetter Queue. And the last one, which is very nice, we can fill the value of some headers automatically for you, which is great for CorrelationId, for partitioning, for sending, distributing IDs as headers. So this is how this is what we can generate, but as I said before, all the plugins are just Maven jars. So you can create your own. If you have some ideas of what implementations you want to have, you can create them, and you can deploy them to Maven Central if you like, as open source. You can publish them in a private Artifactory. You can contribute it to the main project. I mean, it's up to you. This is supposed to be a bazaar. We provide the infrastructure for you to create your own implementations. And this is how easy it is to configure. We have the configuration that I showed you before, and there is an extra, one extra configuration which says Transactional Outbox MongoDB, and the implementation changes from sending the message straight to the broker to saving the message into the outbox. And for business DeadLetter Queue, it's that simple as having a map of exceptions and having the binding, the Spring Cloud strings binding, where you want to send that exceptions. And it works top down, and in the moment that it finds one exception that is part of the hierarchy of the exception that you are throwing, is going to use that binder to send the error. And if it doesn't find anyone, it throws the message up. And for auto headers, it follows this convention. It has this runtime expression that, well, it will fill the value of this header from the message payload customer ID. In reflection at runtime, it's going to get that ID and it's going to fill the. So this is very nice for doing partitioning in Kafka. And for tracing ID, you can also have this expression, tracing ID supplier, which means that it's going to look in your Spring Boot context for a supplier, an object that implements the supplier interface, that is going to provide the ID for a global transaction ID. And enterprise envelope is a little bit more involved or more complex, but it was actually the first implementation that we created, because in this company that I was working, there was a policy that every single message that we wrote to Kafka, it got to be wrapped in an envelope, and inside that envelope was the payload, the business payload. So if we describe every single AsyncAPI that we have with the same envelope, we are describing nothing. So it was a business rule that we got to follow, but at the same time, it was what are we describing? So we create this extension, so we allow the teams, the applications to specify the business payload and then add some extension to the operation, saying what is the class of the envelope, and there is a class that we have a jar for all the corporation that wrap it and unwrap it, the business payload from the corporate envelope. And you can do whatever you want here. You can encrypt some properties, you can compress, you can whatever. You create one class that wraps and unwraps the messages, and you can do open possibilities. Okay, so another thing that we found that is very easy, how to distribute the APIs in a corporate environment, and versioning also. So we found that, at least in the Java world, if you pack it inside a jar file, you can use already your Artifactory, which is widely adopted, very easy distribution because every single Java project will have access, every single IDE will have access. You already have access control for the security. It doesn't matter if it's cloud or if it's on-premise. And you also have, for free, the versioning. Before, we packed everything in a jar, and in the pipeline of the project, we decompress that jar in the target folder, and we use the file. But because, well, that is a little bit cumbersome, we make that ZenWave SDK already can read from inside the class path. So you just need to add your API that was packed in the pipeline inside a jar. You add it to the dependencies, and you can use the prefix class path dot and the full path. Okay, demo time. Today we don't have time for a live coding demo, and I love live coding demos because I prefer to let the code speak. But I hope you get an idea of what ZenWave SDK can do for you. I think, well, you go to the ZenWave SDK, the GitHub page. There is also a repository with a lot of examples, the kitchen sink, which I use for testing all the implementations. And you can also go to getting started from ZenWave. Well, this was the talk. And if you have any questions now. It was a long day already. Yeah. Okay, so this was the first plugin that I wrote, that all the other plugins that I showed you before in the morning, they came after this one because it was, okay, now that I have all the infrastructure for this, why I cannot do, so it came all the rest. But as I say, you can fork it, just the generators. You don't need to fork everything, and you can make it work for your company. And if it doesn't work for your company because there is a bug in the generator that just make contact, you can find me in GitHub or in the social networks. And so thank you very much. And